I'd like to ask AGS Council Member and Co-Founder and Chief Executive Officer of Black Cape, Mr. Al DiLeonardo, to introduce our next speaker. Al?
Thank you, John. As everyone's getting back in and seated, we're glad to continue our partnership with Columbia University today for Geo2050. And we're honored here today to have Dr. Jeffrey Shaman, Dean of the Climate School, who works in the fields of climate and environmental health, climate dynamics, infectious disease, and infectious disease modeling and forecasting. He uses mathematical and statistical models to describe and understand and forecast the transmission dynamics of disease systems on human health. During the COVID-19 pandemic, his team built one of the first models to project the spread and understand the properties of SARS-CoV-2 virus. Dr. Shaman has studied a number of climate phenomena, including wave dynamics, atmospheric wave guides, and tropical psychogenesis. Dr. Shaman was awarded a PhD from the Department of Earth and Environmental Sciences. He received an MA and Master's of Philosophy from Columbia University, and he is currently the Interim Dean of the Climate School. Today, he will talk about, in his presentation, not only geography and climate, but also things that his department and Columbia University are doing to help the cause. So please welcome Dr. Shaman.
Good morning, everyone. It's a pleasure to be here. I'm thrilled to be able to give some remarks here at Geography 2050 and to get to know some of you as well along in the process. It's a pleasure also for Columbia University to help host this event and the Climate School to contribute to the event as well. I'm going to talk a little bit about some of the issues that we're facing, where geography lies within this, and what the Climate School is doing to actually help address some of the crises that we're dealing with. So what I'm showing you here is an analysis that's done by the Goddard Institute of Space Studies, which is just 4 blocks, actually 2 blocks south from where we sit right now. And it shows a reconstruction of estimates of the land-ocean surface temperatures, the anomalies of them, since 1880 up to just a couple years ago. And what it shows is what a lot of us are quite aware of that we are having to contend with, which is that the planet's climate system has shifted, and it's manifesting in a number of ways. One of the principal ones being that we're seeing a warming and elevation of temperatures. So here we see the anomalies of temperature centered around a 1979 to 2000 average, and we can see that before, the 1940s, it was below average relative to that measure, and then since then it has risen precipitously, as a matter of fact, since the 70s. If we break this apart, this has and manifests in a bit of a crisis that we're dealing with our climate system. Not only are the temperatures increasing, but we're seeing extremes coming about in the course of heat waves, and what you see on the left here is a map taken off of Al Jazeera showing a time when it hit 53.2 degrees Celsius in Kuwait, and you can see the temperatures in the entire Middle East region. We've seen similar excursions take place on the Indian subcontinent, extremes recorded in places like Death Valley, heat waves in North America, Asia, and certainly Europe as well have impacted and caused a lot of morbidity and mortality. In addition, there are changes in the hydrologic cycle, in addition to those temperature shifts, that are enormously disrupting how we can produce crops, what it means to the yields that we're going to see, and how well we can feed ourselves. Food security is really being impacted, as well as water security. And these are critical issues that we're going to have to address in the coming years and decades, really as long as humans are on this planet. One of the other associated phenomena we're all aware of is wildfires. And certainly with increasing temperatures and shifts to the hydrologic cycle, this means changes in the vegetative structure of certain landscapes. It's resulted in the drying out of that vegetation, which then serves as tinder for wildfires. And we've seen increases in wildfires all throughout the planet, including places like Indonesia, the southwestern United States, the Mediterranean region of Europe and North Africa. Lots of places in the world where we've seen more fires at higher rates and more damages coming about as a result of that. If we look at the years recently, and to specifically look at the year we're in right now, 2023, we see a marked excursion that has taken place right now, which is a little bit alarming. If you look at this graph, what it shows you is the daily surface air temperatures from January to the end of the year, end of December. The dashed line, let me see if I can use this pointer here. I'm not sure it is a pointer. Ah, yes, well, we'll go with this, sort of. The dashed line right there is the mean. These are 2 standard deviations. The thicker dashed lines going along in black are plus or minus 2 standard deviations. And then all the gray spaghetti that you see there, those are individual years going from 1979 up to 2021. 2022 is shown as the yellow line, and you can see the yellow line actually, see if I can do this again. Well, the yellow line's actually not coming out here. It's red here. The red line is 2022. It was yellow when I looked at it previously. And you can see it's relatively high, but I want to call your attention to the thick black line, which is 2023. And what you can see is something that was reported in the news actually quite considerably, and it starts a little bit in June, but it really takes hold in July, right around here. You see this excursion that has taken place and how there's a real separation for the entirety of 2023 since the beginning of July from the rest of the pack, if you will. We've seen really alarmingly high increases in temperatures. Now, some of this is because we're going into an El Nino. Tropical Pacific phenomenon of ocean atmosphere conditions has moved into an El Nino phase, and that's often associated with a bit of a step function in an increase in temperatures. But we're used to seeing the increases being in hundredths of a degree, not tenths of a degree. If we were to just look at what's happened for Julys over the course of the record, and this is again from NASA GIS going back to 1880, this time centered around a base period from 1940 to 1970. Again, you see that you have below average anomalies for Julys prior to the baseline period, and then afterwards everything is going up, up, up. But if you look at 2023, there's a 0.3 of a degree Celsius jump that took place as a result, well, not as a result, but in association with this month this year. And then we've seen a persistence of those elevation of temperatures. And 2023 almost certainly will go down as the warmest year on record globally by far. So all this is a major concern. We have disruptions to our climate system, and our climate system, of course, is very important because we rely on it and the stability of it for the things we do. I don't think it's any coincidence that during the Holocene, the last 11,000 years, which has been a relatively stable period of climate coming out of the ice ages, that civilization was able to develop. We had reliable temperatures, reliable rainfall that allowed us to build up agriculture in a meaningful way in the Fertile Crescent and expand it around the rest of the world. It allowed us to become less nomadic and to settle down into cities and towns and build so much of what we've seen, and it's facilitated so much of what we do. In the same way that business has a very difficult time dealing with uncertainty, the uncertainty associated with fluctuations or changes in the temperature systems we're used to, the hydrologic cycle we're used to, and the attendant effects that happen to other systems associated with that are going to be things that we're going to have to grapple with in the years, decades, and even centuries to come. Now, one of the other issues that we're certainly going to have to deal with is resource depletion. And this is actually tied somewhat, you could argue, with the climate system because we need these resources for society. We need them to build batteries for the kinds of cars we want to drive going forward. But there's only a finite amount of them. And how we track this and how we reuse this, how we repurpose this is going to be fundamentally important. The same goes with our soils. It is a resource. How we use it and how we're able to actually tap into that to foment food security and use it in a judicious, sustainable way is something that's going to be really critical for society to grapple with. And then there's our water resources. Story of Lake Chad, a Central African transnational lake. It's fed into by rivers from 11 different countries and used to straddle 5 of them. Now has shrunk down to almost no size. And it's been a loss of fisheries and then agriculture, loss of agriculture. There's violence in the region, and it's partly stimulated by this, by the climate crisis, excuse me. Another issue will certainly be biodiversity loss and ecosystem services in general. I just have some charismatic creatures there with the orangutans, and you can certainly see deforestation. But so much of how we handle the land around us and how we care for the resources and what we put into our environment, into the soils, water, and air, is feeding up the food chain and dysregulating it so that we're seeing instabilities, loss of insects, changes in amphibian populations and a real general decline, changes in what's maybe happening with bat populations, though that may be disease-driven, and certainly loss of forest landscape, which is so important as a carbon sink. Pollution, which I just alluded to, is a major factor as well. We have to get control of it. The shot obviously shows air pollution, but we're thinking about pollution in all sorts of ways. We want to think about the water pollutants, the heavy metals, the pharmaceuticals, the agricultural runoff, the nuclear waste, the carbon dioxide byproducts, the plastics. This gets again into resource depletion and how we actually sustainably use the resources on our planet and make the bed for future generations so they have those resources available to them as well. So at a climate school, which we're building out here, our aims are really to bring in science, scholarship, information, approach mitigation and adaptation, and a translation to practice, taking science and scholarship to practice that are really important and a key for solving these problems. It's not enough to identify rises in CO2 and temperature. We have to think about how we're going to inform Congress there. That's James Hansen of NASA GIS testifying to Congress in 1988. And we have to think about how this features into scenarios about what kind of solutions will really work. What do we need to do to get to a net zero carbon economy? How fast do we need to do it if we're not going to see the kinds of severe disruption that are painted out in climate model projections of the future? And of course, there's a critical place for geography in this. We need to incorporate as many advanced geospatial approaches and techniques as possible. We need to be able to communicate it well with beautiful graphics that explain clearly to policymakers, business leaders, the lay public, what the challenges we are confronting are and what we might do about it. And we need to harmonize the analysis of this data and the way the information is used across multiple fields, something that people in this room know very well. That has to feed in all sorts of things related to some of these issues of resource depletion, biodiversity loss, pollution, the climate crisis, and feed into how we think about risk, what we're modeling out, how these various risks come together as individual stressors that form a collective that cause complex problems that we need to deal with. And of course, consistent with the themes of this year's meeting, it's really important to think about how this factors into issues like security and also justice and disparities in the population writ large. So I'm going to tell you a little bit about the climate school in my final minutes. This is the first new school at Columbia University in over 25 years, and it was born out of an Earth Institute that existed to look at Earth problems, environmental problems, sustainability, and climate issues in a transdisciplinary way. Previously, as an institute, the Earth Institute didn't confer degrees because it wasn't a school, and it didn't have a formal faculty. Well, with the Advanced 2 being a school, we now are doing that. We've changed it. The school wants to further knowledge and educate leaders to achieve equitable and just solutions to the changing climate and related sustainability challenges. That is our mission. It builds on, at Columbia University, a legacy of decades of scholarship in this field, from the theory of the ice ages in the 50s and the first mapping of the ocean sea floor by Heesen and Tharp, there's Marie Tharp there, to the coining of the term global warming, to the first El Nino predictions, to talking about the risks of global warming before Congress, to looking at paleohistory, to thinking about climate services, and to looking at the effects of drought more recently. Columbia has had a real investment in geosciences, geography, sustainability for a very long time. At the climate school, we're going to build this out, and we're going to do it through degree programs that are co-developed with schools that we used to do through the Earth Institute. We're starting to pull a couple of those into the school formally to manage them and build them out, and to create professionals to address the climate crisis across many sectors. And I'm going to show you very briefly what I mean about that in a moment. The climate school, in essence, serves as a hub within Columbia University for work on climate and sustainability. And I say that because at Columbia University, I would estimate we have more than 1,000 faculty and researchers in the climate, environment, and sustainability space. I think it's the largest critical mass at any university or institution in the world, to be perfectly honest. And we are only a portion of that because so much of that has been embedded in so much of the other work going on in schools that already exist. One of the programs, the first that we had, is one that we transferred from being what was called a partner program under the Earth Institute under the Climate School, and that's a Master's of Arts in Climate and Society. Since we've done that, we first more than doubled the incoming class for our first climate school class in 2021, and we reached triple digits this year. There are over 100 people studying in this master's program. Almost half of our accepted scholarships went to BIPOC first-generational applicants, and we've also raised some significant tuition and living expensive scholarships for these students. The aim within the school is to provide transdisciplinary understanding, to fill them with actual content knowledge that focuses on understanding of the climate problem. We want to give them core knowledge in things like climate dynamics, chemistry, climate mitigation, adaptation, the energy transition, geospatial analytics, climate communication, and justice. And then we want to partner that with actual work in other sectors. And you're going to see that our graduates are already moving out into many, many sectors. We have a couple of new degree programs that we're going to be launching, hopefully in the fall of 2025. We'll be advertising them come next summer and fall for applicants. We'll accept them, and then they'll enroll at that time. The first is a 2-year MS in Climate and Society. So this is a Master's of Science. Each student will take that core curriculum that exists in our other ones, so there's going to be shared core curriculum, though this one will be even a little bit more quantitative. And then they're going to have an advanced certificate of specialization. They'll move into areas like climate systems and analytics, or climate and food systems, or climate and disaster management, or energy transitions. So you see, we're going to be marrying climate science, sustainability, and analytics together with specific areas of expertise, one of which actually may be analytics in and of itself, and that's where geographic techniques would really be focused on. The second degree that we're also building out is an MS in Climate Finance. We're doing this in conjunction with Columbia Business School, and there's a lot of demand here within the business sector of how we think about markets, how we think about entrepreneurship and green economies, and how we're going to move towards that, and how we're going to capitalize on it and use the market forces to actually advance this more quickly. And that MS in Climate Finance is going to be a 1-year, 12-month program. Again, they're going to be taking that core curriculum that we're developing out, and we've developed out, really, in the climate school, in addition to core courses with MBA students on finance over the course of that degree. I want to also just show you where the alumni from that MA in Climate Society, the one that has over 100 students in it this year, are going. You can see here the statistics for where our 2022 alumni went. And you can see about 15% went into academia, 19% went into the public, working in governmental organizations, 30% went into NGOs in the nonprofit sector, and 39% went into business. And you can see on the right some of the organizations our graduates move into. And what you can see is they're moving across the board. And that's because the demand is across the board for people with quantitative skills and deep understanding of what is going on with our environment, our climate system, and sustainability, who can bring that content knowledge in and apply it into business sectors, who can address food security and water security and waste management and intelligence issues and green economies and environmental policy and legal matters and restructuring the built environment. I can go on and on and on, the types of sectors we're seeing our students go, and the demand is there. I very often say that even though we're a climate school, we're more of a professional school than somebody who's going to just train geoscientists. Our master's students, which are our core programs that we're building out, the students there, for the most part, they're really not interested as much in whether it's going to be 3, 4, or 5 degrees warming by 2100. They want to know what to do about it now. And those are the skills that they want to move into. That's the solution space. Just want to show you some of our cross-cutting faculty. We have joint appointments. We have full-time faculty who are wholly appointed in our school. They work on areas from climate science and dynamics to business solutions, to paleoclimate, to urban planning and architecture, to law, to geochemistry, to food security, to human environmental interactions, to ecosystems, and to energy policy. A very broad reach, and we're going to be building out this faculty even further in the coming years. And our academic footprint, and this is something that will evolve. If you talk to me in 6 months, it probably won't look like this because we're in the process of figuring out. This is our academic strategic plans. Which are the areas are we going to really move into and where we're not? You got a hint of them already in that MS in Climate and Society, where we're building out food security, data analytics and geography, energy transitions, and disaster risk management. Certainly areas that we are going to move into. So I'm out of time, and I just want to thank you for having me here and allowing me to speak a bit. It says look forward to this critically important conference, but I recognize it's actually day 2. So I hope it has been very valuable for you all, and I look forward to hearing more at it. I had a very nice time last night engaging with people over the dinner, and I hope you have a really successful time here. Thank you for having me.